Hello everybody, welcome to the session before lunch, when you're all very hungry. I'll be asking you to raise your hands a few times to get the blood pumping. I was going to say, I'm from Chile, but that got taken care of. So let's start with an informal survey of the audience. Who decided to come here because they thought, I want to just see this guy explain himself out of this topic? Yes! One guy. Okay, fantastic. I hope to prove to you that I can, I suppose. But there's my Twitter handle, and I put a hashtag up if you guys want to contribute to the Twitverse. Yes. Okay, so just a bit of an overview. First, I'm going to go through the origin of technical debt. Then I'm going to look at its evolution because it has had quite an interesting history. And then I'm going to talk about the delivering part. Okay, so first, another audience survey. Who has heard of technical debt before? Well, it was mentioned at least twice in the keynote, so I suspect everybody. Okay, so we have some broken arms there because someone didn't put up their hands. Okay. Now, who would want to explain it to another team member? Yes, thank you for conforming to my expectation there, guys. Okay, so this is very interesting, right? Because conversations between us, between software devs and in our team, normally go something like this. You keep using that word, but I don't think it means what you think it means. Who's seen The Princess Bride? Okay, cool. So about 1% funny, but anyhow, let's move on. So this is a big problem. If I'm trying to talk to my team about something and I can't explain it to them what I want to explain to them, I'm just hoping they have the same understanding. Okay? And in order to have meaningful conversations, like we've been talking about throughout this entire conference, we need to have a common understanding. Otherwise, it's just not going to go well. Okay? So, let's start off with the origin. So, I'm going to set a bit of context, and the first part is, where did this thing come about? Now, I don't normally like to put tons of text onto my slides, and I normally don't like to read to you, but well, I'm talking about something quite specific, and I will be reading to you soon because I forgot the slide was next. Okay, so it was introduced first by a guy called Lord Cunningham in 1992. So in 1992, most of the internet was software developers, so I'm just going to say he introduced it to the internet every now and then, and you guys should know that it was software devs. And he called it the debt metaphor. Somebody else, I'm not quite sure where, because I tried to find, but I couldn't find where, started calling it technical debt. But he refers to it as the debt metaphor. And it was in what could be these days considered to be a blog. He called it an experience report. So he published to the internet developers a body of text that described his experience. And he called it an experience report. And in there he used this metaphor. So let's take a look at the metaphor. So first, and I got this quote off Wikipedia, which is interesting. Shipping first-time code is like going into debt. So far, we're like, yes. That sounds right. Little debt speeds up development so long as it is paid back promptly with a rewrite. We're like, okay, this is getting interesting. Rewrite. I need to explain this a few times to some people. The danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on that debt. Okay? Entire engineering organizations can be brought to a standstill under the debt load of unconsolidated implementation, object-oriented or otherwise. Just a bit on that object-oriented or otherwise. The system he was writing was in Smalltalk, early days of OO, so if that seems like a bit of an anachronism for this time, that's why. So now what I'm going to do is I'm going to show you how everybody reads it. First-time code is debt, paid back with a rewrite. Every minute spent counts as interest on that debt. Then I was actually going to take out this little bit because nobody actually bothers in the little thing other than saying, hey, we will come to a standstill unless we do this rewrite. So, like any good metaphor, it's stuck. Why did it stick? Because all the devs in the world are like, yes, I have a way to describe to these business people. Explain the rewrites. I need to rewrite this code, and in universal terms. And that's kind of what a metaphor is, right? I have some context, you don't have it. But we have another shared common context, that I can talk through. So I'm going to talk in those terms. So, and let's just face it, who doesn't have a credit card? Exactly. And it's like that for everybody. Everybody has a home and a credit card, so there's a beautiful common context that Ward was leveraging to be able to explain this concept, what we think of a rewrite. Okay, so let's look at this evolution. Let's see what happened. All these guys that are going, yes, yes, went, aha, this is the difference between a hack and doing it properly. And just so that I can paint a picture, I couldn't find the link again, but through my research for this particular talk, I found a website. It's about technical debt, like 100% about technical debt. And there was an engineer at Boeing who gave a presentation on technical debt. And his opening slide literally said this, like this same thing. It is the difference between doing a hack job and doing it properly. He had a cool plaster as in a patch, and then a nice, beautifully designed machine, being from Boeing. Other people started to say, well, it's okay to go and write very bad code, poor code, I'll just come back and fix it later. So then, in 2009, Ward came back and made a YouTube video, which has been transcribed in case you want to read it, and there's a link from his original experience report if you want to Google that. And he said, there's been some confusion, people. There's been some confusion. I was using it to explain refactoring to a business person. So let's just take a step back and I'll clarify something. The business person he was trying to explain it to was the product owner of Ycash, which is our financial system. So explaining this, the refactoring in terms of fiscal debt made absolute sense to him. He's like, you have that context, fantastic. Then he said, it's not, I never wanted it to be used to explain writing bad code. All code should always reflect understanding. I think I pushed the button and I didn't want to. Let's see. Okay, never mind. All code should always reflect understanding. And this is a pretty key point that I'm going to go into now. Okay, when I talk about delivery. Even if it's partial. So, I'm very bad at that. You talked before me and before Mark. Rowan! Okay, hope he's not in the audience. Actually, I hope he is. But anyway, so Rowan talked well about the build, measure, learn cycle and how you're going to discover new things as you're busy coding. And this is exactly what Ward was talking about. You're not always going to have a full understanding, so even if it's partial, code needs to reflect that. He was not alone. Uncle Bob came along and said, in the same year, just a month or two later, a mess is not technical debt. He's actually got a blog post that's titled that. It's easy to find if you want to find it. And he went on about the same things. Like, you can't go make a mess and say I'm in technical debt. And then, in this same year, so 2009 was quite a cool year for technical debt, okay, because all these guys, the thought leaders of the industry were going, hey guys, what is this all about? Martin Fowler came along. And if he was here last year, maybe he would be in the audience. If I was to give it and he said, well, I don't think the right question is it technical debt or isn't it technical debt? That doesn't seem to be a very constructive question. And he reinforces that it's a metaphor. And again, metaphors are tools for communication. In this specific instance, it's a tool for communicating about design. And again, Rowan talked a lot about design, so I'm not going to go into that too much. But he said, well, let's stop trying to determine whether it is or isn't technical debt. Let's classify it. And he came up with two axes or two categories, and that's responsibility and awareness. And out of that, he made a technical debt quadrant, hence the heading. But I'm going to show you the quadrant. So, on the one side, there's responsibility, and we have reckless and prudent. And on the other side, there's awareness, and we have deliberate and inadvertent. So when we're in the top left quadrant here, and we're reckless and deliberate, guys know they're making a mess. And they're like, we don't have time for this, we don't care. And it's very much about the attitude. I'm so awesome, I can just make it work. You know, the same thing, the stuff that Rowan was talking about, that the guy that everybody relies on to be able to do the stuff, and everybody else is just around the fringes. In this quadrant over here, you have our students, which is like, what's there, man? You know, they just don't know. It's guys who they don't know they're being reckless; they're just producing code. And somebody else comes along and goes, "What is this?" Okay, and then the top one, I put two examples because this one is Martin Fowler's example, and this one is one that I've experienced personally. So we must ship debt now with specific consequences. And we've heard this reinforced by Aslam and by Rebecca, three of the keynotes actually, saying that sometimes you need to take on technical debt. But it's not, we can take it on and it's this thing that'll just sit there and we won't bother with it. We can use it as a tool. So then my one that I've experienced is we write some code. It's not reflecting my understanding. So I know there's debt there, and we've got a little item on the board, but we touch that code maybe every 3-4 months, maybe. So then, and the interest is small because it's maybe 50 lines. You know, like, well, that's not too bad. So we've been prudent and we've been very deliberate. We're like, this is not. It's too much effort to go and refactor this out. And then the last one is the one. Now we know how we should have done it. Who's ever experienced that? Okay, so where are the rest of you in the boat? Either that or you guys have lots of broken arms. You know, just saying. You can't be that hungry. Anyhow, so let's just kind of place some faces in this quadrant. We have, the images might be a bit small for the guys who like staring at Twitter instead of here, but we have Robert Martin and Fowler down at the bottom. That's how they like to work, okay? But the reality is, the rest of us are kind of just scattered everywhere. And it's not because we're being incompetent, it's just that's the reality of the project. You might come onto a project where the developers have been reckless and inadvertent, and your job might be to drag them out. But then this is the metaphor you use to communicate to them that this is what's happening. So this is why Martin was saying that it's not really constructive to constrain it to this quadrant over here, because these exist, and just pretending they don't is not a good, not very healthy, especially for communication. So, I kind of talked about that. And the one thing that I find powerful about this is that it always stimulates meaningful conversations. Very hard conversations, but very meaningful conversations. But those are the ones, and again, it's been reinforced throughout this entire conference so far, that those are the ones we need to have. I like this. I like it so much I had to put this there so I didn't forget to say I like it at this point in time. Okay. Now, how are we doing for time? Sorry, Shanaz. That's great. 15 minutes. That's fine. Okay. So let's talk about this delivering thing. And now hopefully the guy standing on the Twitter that put up his hand when I asked about how I'm going to talk out of this. He's still not looking this way. Hello. Okay, so now we'll talk about this delivering thing. So, what do you mean? And this is kind of what I was drawing attention to earlier, where we're technical people. We're talking about technical problems. And we're using this metaphor, but none of us can decide on what we're actually trying to map it back to. So, I'm going to try to help build a common understanding between you and myself in this gigantic monologue, and I'm going to map the metaphor to the dev process. So, let's take a look at this. How many devs in the house? Okay, cool. Fantastic. So, stop me, and you can actually physically stop me and disagree with me if you don't agree with this, but there's a developer that gets a feature in a story, and you write some code. And then from that code, you learn some stuff. Now, it could be domain knowledge. Let's just say, oh, this isn't actually a user, it's a customer. Okay? So, then he carries on writing some code. And then it might be he does some learning about the solid principles. As in, I finally understand why you do dependency inversion. Yes! Well, I understand why on earth you want lots of small interfaces, okay? Then he learns a bit more, and then he writes some more code, and now he might learn a bit more about the domain. And this is how we go. It's that build, measure, learn cycle that was talked about a bit earlier. And we carry on. It could be tech, it could be learning about anything. And the point is here is that the developer is learning, okay? And it's important to know that you're going to continually learn about all these various things. That's why you're going to continue to learn and deepen your knowledge about the various things. It's not just going to be, I will learn once off about everything I need to know about the domain. That just doesn't, it's not realistic. So let's look at mapping the metaphor. Most people agree, and it's been said a few times as well, that here's the asset, here's the thing that I can give to the client, compiled, and may even include tests. And this here's the principle. So who here wants to whip out their phones and Google principle? Because I wanted to, I don't know what I meant, but the principle is what you pay interest on. it's also the thing you have to pay back. Right. So if I take out a loan out of R1 million, the bank is going to charge me interest on that R1 million, and I have to pay it back at some point in time. And some of you might be thinking, okay, that's great. How can learning be debt? This is weird. Who thinks it's weird? Okay, that's not what I wanted. Who doesn't think it's weird? Oh my gosh! All of my surveys are useless up to this point in time. How am I meant to make a decision now? Okay. So let's just proceed, people. Okay, so the dev has an idea, and he wants to put it into code. So he goes and tries. Then he goes, where's my user class? What's going on? Then he has to read through the code, goes spelunking a little bit, and goes, aha, it's called person now. Yes, okay, I can do my code. But what he's done is he's built up a temporal mapping. He now, in his head, has to remember user is equal to person, right? And once he's done that, he can materialize his idea into code. He can be, yes, I understand now, I can do the code. The problem is this translation. The code has one state, and his mind state is different. He's got a different picture in his mind, and it's because of this learning that's only sitting in his head. It's not reflecting the code, so he's having to build up that mapping. This costs cognitive resources. Now, if you go to Travis's talk a bit later, he's going to be talking about neuroscience and software dev a bit. And cognitive, like your prefrontal cortex can keep track of less than 10 things at one time. So every time you're having to build mapping, you're using your problem-solving part of your brain to remember things. And that is the interest.